Grade 11, hello again. At the beginning, sorry للطلاب اللي انتقدوني ما كنت عم بسلم عليكم. So I hope you are doing well. I'm really missing you guys. وبتمنى انه تكونوا عم تستفيدوا من الفيديوهات وعم تفهموا منها. So guys, today we have multiple choices test in chapter 20. So we're gonna go question by question, then you have a homework. Let's start. Before I solve each question, I'm gonna give you like 30 seconds. So please try to solve the question by yourself first. So, which of the following equations correctly describes Faraday's law of induction? So, for the electromotive force, is it A or B or C or D? So you have 30 seconds. Try to think. Okay, let's start with A. EMF equal to minus N, number of terms. Delta AB tan. No, it's incorrect because it's not tan. So it's impossible to be A. Let's go for B. EMF equal to N delta A B cosine theta divided by time. Actually, it's correct, but here there's no negative sign. So it's incorrect. It's not B. Okay, what about D? Electromotive force equal to M, mutual induction? No, it's not M. So it's C, because it's equal to minus N delta AB cosine theta divided by T. So the correct answer is C. Which of the following would not increase the electromotive force by a generator? Would not increase the electromotive force by generator. So, first option, rotating the generator coil faster. Faster. Guys, faster, that's mean less time. Less time, that's mean more electromotive force. So no. If we are using option A, we will have more electromotive force. B, increasing the strength of the generator magnets. That's mean more B, more magnetic field. If we have more magnetic field from here, so assume we have more B, that's mean we have more EMF. So no, it's not correct. Increasing the number of turns of wire in the coil, that's mean we have more N. Again, when we have more N, that's mean we have more EMF. So it's incorrect. Reducing the cross-section area of the coil. That's mean we have less A. When we have less A, that means we have less electromotive force. So the correct answer, D. So here he's asking to find the RMS electromotive force. So for example, if we have the maximum value, what we have to do to find the RMS value? Is it times 2, times radical 2, divided by radical 2, or times half? I think it's an easy question. For sure, it's divided by radical 2 because as we said before, IRMS it's equal to the maximum value divided by radical 2, which is equal to maximum value times 0.7, because 1 divided by radical 2 it's equal to 0.7, so it's the same even it's divided by square root of 2 or it's times 0.7. So the correct answer, H. Now is the tricky question. Try to solve this question. So you have 1 minute to solve this question. So a coil is moved out of a magnetic field in order to induce an electromotive force. The area of the coil is increased. So first given the area increased by 1.5 times. Write it down, please. Then extra wire is used in the coil so that the number of the turns is doubled. So second given number of the turns is doubled. Write it down, please. If the time, so third given, the time is reduced by half. So the time is reduced by half, third given. And the magnetic field strength, which means B, remains unchanged. So it's the same B. How many times greater is the new induced electromotive force than the original induced electromotive force? So we have three givens, don't forget. The area increased by 1.5 times, then the number of the turns N is doubled, then the time reduced by half, so times 0.5. Try to find the answer. So let's solve it together. Now, as we said, we have three givens. First one, A, the new A, it's equal to 1.5, the new N, 2, and the new time, 0.5. Okay, from the formula, EMF is equal to negative N times delta AB cosine theta divided by time. So, here the area, and the new area is equal 1.5, that's mean times 1.5. And the new N, it's 2, so times 2. The new time, 0.5, so it divided by 0.5. So the new value for the electromotive force is equal to 2 times 1.5 divided by 0.5. The answer 6. So the correct answer J 6 times, because again it's times 1.5 area times 2 number of turns divided by time, which is 0.5. So 1.5 times 2 divided by half, it's equal to 6 times. Now the alternating current through an electrical has a maximum value of 12 ampere. Maximum value. That means we have I max equal to 12 ampere. What's the RMS value of this current? So given I max equal to 12, find the IRMS. We said before, IRMS is equal to I max divided by radical 2, or IRMS equal to I max times 0.7. So 12, the I max here 12, divided by radical 2, it's equal to 8.5 ampere, the IRMS value. Now guys, here you have a homework. Please try to solve it by yourself. Good luck. See you next session, inshallah.